Welcome students, myself Kale SL, Rayat Shikshan Sanstha's RBNB College Rampur. We see here 11 Science Mathematics Part 2, lecture number 3rd, topic number 7, limits and exercise 7.1 and 7.2. In the previous video lecture, we have completed question number 1st, question number 2nd of exercise 7.1 and also question number 3rd. Only two problems are left in the question number 3rd. So let us see problem number here 8, question number 3, problem number 8. Limit x tends to 7, limit x tends to 7, x to the power 3 minus 343 divided by square root of x minus square root of 7. Now here we have to evaluate this limit. Question number 3rd is evaluate the following limits, and 8th problem, limit as x tends to 7, x cube minus 343 divided by root x minus root 7. Firstly, we have to decide whether denominator is 0 while putting x is equal to 7. So if we put here x is equal to 7, we get root 7 minus root 7, that means it is 0. So denominator is 0. So we cannot put directly x as a 7. We have to solve this problem so that we remove this difficulty for which denominator is 0. So here we write this is equal to limit as x tends to 7. Here x to the power 3 minus this 343 is the third power of some number, because here power is 3. Here also this is the power third of some number. Which number? That number should be 7, because here limit x tends to 7. So here 7 to the power 3. See here, 7 to the power 3 is equal to 7 into 7 into 7. 7 sevens are 49 into 7. So it is equal to 7 nines are 63 and 7 fours are 28 and plus 6, 28 plus 6, that is 34. So this is 343. Similarly, now next here in the denominator we write this square root. Square root we write x to the power half minus here x to the power 7 to the power, here square root, so take power 1/2. And now we have seen one important formula in the previous lecture. Limit as x tends to a, limit as x tends to a, x to the power n minus a to the power n divided by x minus a. Here powers are same, x to the power n minus a to the power n, and divided by this x minus a, x tends to a, it is equal to n into a to the power n minus 1. We are interested to this a to the power n. So n into a to the power n minus 1, this is the formula. Now in the numerator powers are same, x to the power 3 minus 7 to the power 3. So divided by x minus 7, we must have divided by x minus 7, but in the denominator there also x to the power 1/2 minus 7 to the power 1/2, means here also powers are same. So here we divide numerator and denominator by x minus 7. We need here x minus 7 to numerator and denominator to use this formula. So we take here we write divide numerator and denominator by x minus 7. Okay, so we get here, so this x to the power 3 minus 7 to the power 3 divided by x minus 7, and in the denominator x to the power 1/2 minus 7 to the power 1/2 divided by x minus 7, and we now take limit to numerator and denominator separately using the algebra of limits. So here it is limit as x tends to 7, also here limit as x tends to 7. And now use this standard formula, that is limit x tends to a limit x tends to a, x to the power n minus a to the power n divided by x minus a. So we use n into a to the power n minus 1. From this we write this n into a to the power n minus 1 we write from this term. Also here x to the power 1 half minus 7 to the power 1 half divided by 7 x minus 7 and x tends to the 7. So use that standard formula. So it is equal to 3, this n here 3 into 7 to the power 3 minus 1, okay, divided by here this 1 half, here now n is 1 half, so 1 half into 7 to the power 1 half minus 1, and so we get, so it is equal to 3 into 7 to the power this 3 minus 1, that is 2, divided by here 1 half and 7 to the power this 1 half minus 1, 1 half minus 1, that is minus 1 half, okay. And now we write this as this 3 into this 1 half, we write 2 by 1, this 7 to the power 2, it is 49, and into this 7 to the power carry to numerator, it become plus using the rule of indices. So this 3 as it is, this 1 half we write in terms of multiplication 2 upon 1 into this 7 square is 49, into this 7 to the power minus 1 half we shift to numerator, it become plus. So 3 into 2 6 and 6 into 49, so 49 into 6, 6 9s are 54, so 5 and 6 4s are 24 and 24 and 5 29, so it is 294, and this 7 to the power half, 7 to the power half means square root of 7. This is the final answer for this problem. Now we see here last 9th problem in this question number 3rd. So 9th problem here, limit x tends to 1, limit x tends to 1, x plus x cube plus x to the power 5 plus up to dot dot plus x to the power 2n minus 1, 2n minus 1 minus n divided by x minus 1. This is the 9th problem. X plus x cube plus x to the power 5 plus up to dot dot x to the power 2n minus 1 minus n upon x minus 1. Now here we write this n. Suppose here 4, then we write 4 as 1 plus 1 plus 1 plus 1. It means we take the addition of 1 4 times, then it is 4. So here we write n as take the addition of 1 n times. That means here 1 plus 1 plus 1 plus up to dot dot n times. Take the addition of 1 as n times, that is n. Okay, so this limit we write limit x tends to 1, x plus x cube plus x to the power 5 plus up to dot dot x to the power 2n minus 1 minus we write this n as 1 plus 1 plus 1 plus up to dot dot n times, okay, and divided by this x minus 1 as it is, divided by x minus 1. Now it is equal to limit as x tends to 1. Here we take x, this x and this 1 and with minus sign, so minus 1, so x minus 1, okay. Then plus here x to the power 3, then next 1 with minus sign, that is minus 1, plus this x to the power 5, then third 1, that means this one with minus sign, x to the power 5 minus 1, okay, plus up to dot dot, here we take this nth term x to the power 2n minus 1, x to the power 2n minus 1, and nth term here take nth one with negative sign, that is minus 1, and divided by whole divided by x minus 1. Now we divide by x minus 1 separately to every term, with this limit as x tends to 1. Take limit as x tends to 1 to every term and divide by x minus 1. So we get here limit as x tends to 1, x minus 1 upon x minus 1 plus this x cube minus 1 upon, take this limit as x tends to 1, limit as x tends to 1, x to the power 3 minus 1 divided by x minus 1 plus limit as x tends to 1, x to the power 5 minus 1 divided by x minus 1 and plus up to dot dot plus limit as x tends to 1, x to the power 2n minus 1 minus 1 divided by x minus 1. Now here this x minus 1 and x minus 1 get cancelled, same terms. Now here x to the power 3, we write this one as 1 to the power 3. Here x to the power 5, here we write 1 to the power 5. 1 to the power anything that is equal to 1, we know. And lastly here we take 1 to the power 2n minus 1. 1 to the power anything, it is 1. And now use the standard formula. Which standard formula? That is limit x tends to a. Limit x tends to a, x to the power n minus a to the power n divided by x minus a is equal to n into a to the power n minus 1. Okay. So here we write this n into a to the power n minus 1 from this term. So see this 1 to the power 3, here 1 to the power 5 and here 1 to the power 2n minus 1. Firstly, so this is equal to limit as x tends to 1, here 1 is remain. And we want to put the value of x as 1, but there is 1 which is constant, so keep it as it is 1 plus, here use the formula from this term 1 to the power 3. That is 3 into 1 to the power 3 minus 1, okay, plus here 1 to the power 5, here we write 5 into 1 to the power 5 minus 1 plus up to dot dot lastly this 2n minus 1, 2n minus 1, 1 to the power 2n minus 1 minus 1. So we get here 1 plus 3, 1 to the power 3 minus 1, 3 minus 1 that is 2, 1 to the power 2 that is 1 into 3 it is 3 plus here 5 into 1 to the power anything that is equal to 1. So 5 into 1 that is 5 plus up to dot dot plus here 2n minus 1, 2n minus 1 to the power anything that is equal to 1. So this is the addition 1 plus 3 plus 5 plus up to dot dot plus 2n minus 1. So we write this addition in terms of summation notation. So here we write this addition, it is equal to summation. Here general term, last term is 2n minus 1. Last term is 2n minus 1. So we write here 2r minus 1. Instead of n we take here now r, general term. And now r from 1 to n because these are n terms. Okay, r from 1 to n. So it is equal to, now we multiply by this summation to every term inside the bracket. So we get here summation r from 1 to n twice r, okay, minus summation r from 1 to n and this one. Now these two constant take outside the summation. So we write here these two outside the summation. And we have seen in sequence and series the formula for summation of r. It is n into n plus 1. These two as it is, formula is n into n plus 1 divided by 2. Okay. And minus here summation of 1. We take the addition of 1 n times, that is n. And now these 2 and 2 get cancelled. 2 and 2 get cancelled. So now we multiply by n into n square plus n into 1 n and this minus n. Now this plus n and minus n get cancelled. So the final solution is here n square. Okay, so in this way we have completed here 9th problem in the question number 3rd, and exercise 7.1 is completed. Now we start here exercise 7.2, and this exercise 7.2 depends on the methods of factorization and factorization of quadratic expression or any expression. How to factor we know, so we use the trick of factorization. Here question number first, evaluate the following limits. Question number first, evaluate the following limits. First example, limit z tends to 2. Limit z tends to 2, z square minus 5z plus 6, z square minus 5z plus 6 divided by z square minus 4, z square minus 4. Now see here, our rule is whether denominator is 0. If denominator is 0, then we have to solve this problem. We have to use formula, or by any other method we have to remove that difficulty where denominator is 0. Now here put z as 2, so 2 square, that is 4 minus 4, it is 0. So we have to solve this problem. Now here in the numerator quadratic expression, so we factor this quadratic expression. We factor this plus 6. Take here 2 numbers so that their product is plus 6 and addition is middle term, that is minus 5. So 3 2s are 6. 3 2s are 6. Here middle term is minus 5. So take both minus. So minus 3 minus 2, that is minus 5. And minus 3 into minus 2, that is plus 6. So we write this as limit as z tends to 2. In the numerator, in denominator we write here z square minus here 4 we write 2 square, and in the numerator now we take the product of 2 brackets where first is here z. Now here minus 3 and minus 2, so take here this minus 3 and minus 2. When we write this directly, when there is a coefficient of quadratic term is 1, coefficient of z square is 1, then we write direct factors. Otherwise we have to split the middle term. Okay, now so this is equal to limit as z tends to 2. In the denominator we use the formula a square minus b square. A square minus b square, that is equal to in first bracket the addition and in second bracket subtraction. Okay, so here a plus b means here z plus 2 into z minus 2, and now here z minus 3, z minus 2. We cancel this same factor z minus 2, z minus 2, but here we have to write, since z tends to 2, we have given z tends to 2 means z not equal to 2. Z not equal to 2, z approaches to 2 but not exactly 2, it is very near, very close to 2. So carry this 2 on the left hand side, we get z minus 2 not equal to 0. This z minus 2 not equal to 0. When we carry here 2 on the left side, here remains 0. So z minus 2 not equal to 0, so we cancel this common factor. We have to write always this step. And now here we put directly z as 2. Firstly put in the denominator. In the denominator 2 plus 2 4, so it is not 0. So directly put z is equal to 2 in the numerator and denominator. So 2 minus 3 divided by 2 plus 3. 2 minus 3, that is equal to minus 1 divided by 2 plus 3, 5. So this is the final answer, minus 1 upon 5. Now second problem. Limit as x tends to minus 3. Second, limit as x tends to minus 3 here. x plus 3 upon x square plus 4x plus 3. X square plus 4x plus 3. So observe this problem. If in the denominator, if we put x is equal to minus 3, whether it is 0. So minus 3 square 9. Okay, and 4 into minus 3 minus 12. This term is minus 12, and this 9 and this plus 3, that is 12. 12 minus 12, 0. So denominator is 0, means we have to solve this denominator so that we can remove that difficulty after the solving. So we factor this denominator. This is a quadratic expression. We factor this plus 3. 3 ones are 3. Okay. Now here middle term is plus, so take both plus. So we get here solution of this. Limit as x tends to minus 3. In the numerator here x plus 3, and in the denominator we write directly factor. Why we write directly factor? Because here coefficient of x square is 1. So we write directly x plus 3 and x plus 1. And now we cancel this x plus 3. But before to cancel this, we write here since x tends to minus 3, therefore x not equal to minus 3. Remove this tends to sign and write here not equal to. And then carry here on the left hand side, we get here x plus 3. When we carry to left side, it become plus. So x plus 3 not equal to 0. And then we cancel this x plus 3 and x plus 3. And now here remains 1 upon x plus 1. So now put x as a minus 3. So we get here in the numerator 1 divided by x as a minus 3 plus 1. So it is equal to 1 upon minus 3 plus 1, that is minus 2. Always write this minus sign in the numerator. So minus 1 by 2. This is the solution of second problem. Now we see here third problem. Limit y tends to 0. Third problem is limit y tends to 0. 5y cube plus 8y square. 5y cube plus 8y square divided by 3y to the power 4 minus 16y square. Minus 16y square. Now if we put y is equal to 0 in the denominator, denominator is 0. 3 into 0, 0, minus 16 into 0, 0. So we have to solve this problem. So this is equal to limit as y tends to 0. Now we take here y square common in the numerator, also in the denominator. So y square in the bracket, here 5, here y square outside the bracket, so y, here plus 8 divided by, here take y square common, so y square, here 3 and y square minus 16. Now we cancel this y square. So before to cancel this y square, we write here since y tends to 0, therefore y not equal to 0. Okay, therefore y square not equal to 0. Y not equal to 0, so y square not equal to 0, and then we cancel this y square. And now here when we put here y is equal to 0, 3 into 0, that is 0, 0 minus 16, we get minus 16 in the denominator. So put directly y as 0 in the numerator and denominator. So it is equal to 5 into this 0 plus 8 divided by 3 into 0 square minus 16. So 5 into 0, that is 0 plus 8 divided by 0 square, 0 into 3, that is 0 minus 16. So 8 upon minus 16. 8 ones are 1 and 8 twos are 8 ones are 8 and 8 twos are minus 16. So it is minus 1 upon 2. This is the final solution. We write this minus sign always in the numerator. So in this way we have completed this third problem. Now fourth problem. Limit as x tends to minus 2. Fourth problem. limit x tends to minus 2, minus 2x minus 4, minus 2x minus 4 divided by x cube plus 2x square, x cube plus 2x square. Check whether denominator is 0. So we put x as a minus 2, minus 2 cube, minus 2 cube is minus 8. Here minus 2 square, 4, 4 into 2, 8, plus 8, and here minus 8 plus 8, 0. So denominator is 0. So we cannot put directly x as minus 2. We have to solve this problem by any method. Now observe this problem. So it is equal to limit as x tends to minus 2. In the numerator, we take here minus 2 common, minus 2 in the bracket x plus 2. Get it? Minus 2 into x minus 2x, minus 2 into 2, that is minus 4. Here take x square common, x square in the bracket here x and plus 2. So same factor, we cancel this x plus 2. Before to cancel this x plus 2, we write here, since x tends to minus 2, we have given this x tends to minus 2, means x not equal to minus 2, carry this minus 2, so x plus 2 not equal to 0, and then we cancel this x plus 2. And now here when we put x as a minus 2 in the denominator, now denominator not equal to 0, so put directly x as a minus 2 where x present. So it is equal to, in the numerator minus 2 as it is, divided by x square, x is here minus 2, it's a square, so it is equal to minus 2 upon 4, minus 2 square 4, 2 1s are 2, 2 2s are 4, so it is equal to minus 1/2. This is the solution for the fourth problem. Now last problem in this question number first, fifth problem, limit as x tends to 3, limit x tends to 3, x square plus 2x minus 15, x square plus 2x minus 15 divided by x square minus 5x plus 6, x square minus 5x plus 6. Okay, now see, when we put x as a 3 in the denominator, whether denominator is 0, so 3 square, that is plus 9, and this plus 6, that is 15 plus 15. Now middle term, minus 5 into 3, that is minus 15, plus 15 minus 15, 0, so denominator is 0. So we have to solve this. Now we have to use factorization method. We factor numerator also denominator. So here in the denominator we have to factor this plus 6. We have to factor this plus 6 so that product is plus 6 and addition is minus 5. So 3 2s are 6. Okay, middle term minus 5, so take both minus, and in the numerator we have to factor this minus 15, so 5 3s are 15, 5 3s are 15, and here we want plus 2, so this plus 2 and this minus, see here 5 into minus 3 minus 15, and 5 minus 3 plus 2, here minus 3 into minus 2 plus 6, and minus 3 plus minus 2, that is equal to minus 5, and here coefficient of x square is 1 in the numerator also in the denominator, that means we write here direct factors. So it is equal to limit as x tends to 3 in the numerator minus 15, here minus 15, so x plus 5 and x minus 3, x plus 5 and x minus 3. In the denominator here plus 6, x minus 3, x minus 2, x minus 3 and x minus 2, very easy. Now we cancel this common factor, but we write here x tends to 3, means x not equal to 3, carry 3, so we get here x minus 3 not equal to 0. So x minus 3 not equal to 0, so we cancel this x minus 3. And now when we put x as a 3 in the denominator, now denominator not equal to 0. So we put directly x is equal to 3 in the numerator, also in the denominator. So we get here x as 3, so 3 plus 5 divided by 3 minus 2. 3 plus 5, that is 8, divided by 3 minus 2, 1. 8 upon 1, that is equal to 8. So this is the solution of the fifth problem. In this way we completed here question number first of exercise 7.2. Now we start here question number second. Question number second here, evaluate the following limits. Only write here second. Question is same. Evaluate the following limits. First problem, limit u tends to 1, u to the power 4 minus 1 divided by u to the power 3 minus 1. Now always check whether denominator is 0 after putting u as 1. So 1 cube 1, 1 minus 1 0. So we have to solve this. We cannot put directly u as 1. We have to remove this difficulty. So we have seen one standard formula, x to the power n, here power, so x to the power n minus a to the power n, x to the power n minus a to the power n upon x minus a, limit as x tends to a, it is equal to n into a to the power n minus 1. We have to use this formula here. So here u to the power 4, it is equal to limit u to tends to 1, u to the power 4 minus this 1 to the power 4 divided by u to the power 3 minus 1 to the power 3. We write 1 as 1 to the power 4 because here power 4. Here we write 1 to the power 3 because here power 3. Now divide numerator and denominator. We want here divided by u minus 1. Also here divided by u minus 1. So divide numerator and denominator. Divide numerator and denominator by u minus 1. And so we get here u to the power 4 minus 1 to the power 4 upon u minus 1. Similarly in the denominator, u to the power 3 minus 1 to the power 3 divided by u minus 1. And take separate limit to numerator and denominator by algebra of limits. So here we write limit u tends to 1 and here also limit u tends to 1. Okay. And now here formula is n into a to the power n minus 1. That means we write from this term 1 to the power 4, here 1 to the power 3. So in the numerator 4, this n is here 4 into 1 to the power this 4 minus 1 divided by in the denominator this 1 to the power 3. So we take here 3 into 1 to the power 3 minus 1. Okay. So here it is equal to 4 upon 3. 4 into 1 to the power 4 minus 1, that is 3, and here 1 to the power 3 minus 1 2. 1 to the power anything, that is equal to 1. 1 to the power 3, that is 1. Here 1 to the power 2, it is 1. So 4 into 1, that is 4 upon 3 into 1, that is 3. So the solution is 4 upon 3. Now let us see here a second example. Second example, limit x tends to 3. Limit x tends to 3 in the bracket 1 upon x minus 3 minus 9x upon x to the power 3 minus 27. Okay. So how to solve this problem? Here if we put x as a 3, 3 minus 3 0, here also 3 cube, that is 27 minus 27 0. So we write this as this is equal to limit as x tends to 3 1 upon x minus 3 as it is minus 9x upon, we write this x cube minus 27 as 3 cube. Okay, and now use the formula a cube minus b cube. A cube minus b cube, that is equal to in first bracket a minus b and in second bracket a square plus product of these ab and plus b square. Okay, these are the factors of a cube and a cube minus b cube. So we write here. So it is equal to limit as x tends to 3 in the bracket 1 upon x minus 3 minus 9x upon x minus 3 in second bracket x square plus 3 into x, that is 3x, plus 3 square, that is 9. Okay, a square plus ab and plus b square. So it is equal to limit as x tends to 3. We take here LCM of this x minus 3 and x minus 3 into x square plus 3x plus 9. So LCM is x minus 3 into x square plus 3x plus 9. We write here denominator as x minus 3 into x square plus 3x plus 9. Okay. Now here x minus 3, if we remove this x minus 3, we get here x square plus 3x plus 9, means here x square plus 3x plus 9, we have to multiply this to this denominator also numerator. So multiply by x square plus 3x plus 9 to this one. So 1 into x square plus 3x plus 9. Now here minus sign. Now this denominator and these are same. So here only remains 1. So multiply by 1 to 9x. So 9x into 1. 9x into 1. So we get here, this is equal to limit as x tends to 3. 1 into this, that is x square plus 3x, x square plus 3x plus 9. And minus 9x into 1 minus 9x. So minus 9x, this is minus 9x and plus 3x. So minus 6x. So middle term is minus 6x. Middle term is minus 6x divided by here x minus 3 into x square plus 3x plus 9. X square plus 3x plus 9. Now factor this numerator, we factor this plus 9, plus 9, 3 3s are 9, okay, here minus 6, so take both sign minus, minus 3 into minus 3 plus 9, minus 3 plus minus 3, that is minus 6, and so we write here limit as x tends to 3. We write direct factor, that is x minus 3 and also x minus 3 and divided by this x minus 3 into x square plus 3x plus 9. And now we cancel this common factor. But before we write here x tends to 3 means x not equal to 3. So x minus 3 not equal to 0, and so then we cancel this x minus 3. And now when we put x as a 3 in the denominator not equal to 0 because here all are plus. So put directly x as a 3. Numerator may be 0, may not be 0. In numerator, if it is 0, never problem. Answer may be 0. But denominator should not equal to 0. So when we put x is equal to 3 in the numerator, we get 3 minus 3 upon this 3 square plus 3 into 3 and plus 9. That is, it is equal to 0 upon 9 plus 9 plus 9, that is 27, and 0 upon 27, that is equal to 0. So the answer is here 0. So this is the solution of the second problem. Now third problem. Limit as x tends to 2. X cube minus 4x square plus 4x. X cube minus 4x square plus 4x divided by x square minus 1. X square minus 1. Firstly check whether denominator is 0. If denominator is 0, then we have to solve problem by using formula, by factorization method, by rationalization method, anyway. So here we put x as a 2 in the denominator, 2 square, that is 4, 4 minus 1, that is 3, it is not 0. So put here directly x as 2 because denominator is not 0, and so this is equal to x is 2, so 2 cube minus 4 x is 2, so 2 square plus 4 into 2 divided by x is 2, so 2 square minus 1. 2 cube here 8 minus 2 square 4 4 are 16 plus 4 into 2 8 divided by here 2 square, that is 4 minus 1. Here 8 plus 8, that is 16 minus 16 upon 4 minus 1 3. So here it is 0 upon 3. 0 upon 3 means 0. Answer here 0 for the third problem. Now next fourth problem. Fourth problem here, problem is different. Here limit delta x tends to the 0. We have given here triangle. Triangle means here we read it as delta. Limit delta x tends to the 0. X plus delta x. X plus delta x bracket square. Delta x is variable here. Delta x approaches to the 0. Okay. Minus 2 in the bracket x plus delta x. Minus 2 in the bracket x plus delta x plus 1, then minus in the bracket x square minus 2x plus 1 upon delta x, upon delta x. So here delta x tends to the 0, so if we put delta x as a 0, denominator 0, so we have to solve this problem. Now here we expand this x plus delta x bracket square, multiply by 2 inside the bracket and so on, multiply by minus sign, etc. Okay, so expand this using the formula a plus b bracket square, that is a square plus twice ab plus b square. So it is equal to limit as a delta x tends to the 0, x plus delta x bracket square, that is a square means x square plus 2 into x into delta x plus delta x bracket square minus here multiply by 2, so 2 into x minus 2 into delta x minus here x square and minus minus plus 2x, here plus 1 remain, I think here plus 1 remain, minus 2 into x minus 2 delta x, then here plus 1, this plus 1 minus this x square minus minus plus 2x and then minus 1 divided by delta x. Okay, now here minus this minus 2x and plus 2x get cancelled, plus 1 and minus 1 get cancelled, here plus x square and minus x square get cancelled. Okay, so we get here limit as a delta x tends to the 0, here 2x into delta x, now here plus delta x square and here minus 2 times delta x, these terms remain in the numerator divided by delta x, here delta x, here delta x square, here delta x, take delta x common. And so we get here limit, because we have to remove this delta x, denominator is 0, so we take delta x common. So limit delta x tends to the 0, take delta x common in the bracket, here it is 2x plus here 1 delta x remain and minus here 2 delta x outside the bracket, so here minus 2 and divided by this delta x. Okay, now we cancel this delta x. So before to cancel this delta x, we write here since delta x tends to the 0 means delta x, we remove this tends to sign and write here not equal to 0. Since delta x not equal to 0, then we cancel this delta x. And now here denominator is 1, which is not 0. We have to put the delta x at 0. So put delta x is equal to 0 in the numerator only. So we get here 2x as it is. We have to put delta x 0, not x 0. Okay. So twice x as it is plus delta x is 0 and this minus 2. So we get the solution as 2x minus 2. This is the final solution. So in this way we have completed here fourth problem, and now only 2 problems here remain. We see these problems in the next video lecture. Okay, we stop here.